right, our next speaker is Phillip Davis, and his talk is titled Invalid JSON in the iRODS Audit Plugin and Building Out the REST Endpoint. Take it away.
All right, so as Corey said, my name is Phillip, and I'll be talking about those two projects that I worked on over the summer with iRODS. By way of a brief introduction, I'm a first year's master's student at Appalachian State studying computer science. And I live in Morganton, North Carolina, where I absolutely love it because it's gorgeous and we live in the mountains. And outside of computer science, I've taken up rock climbing and learning Old English recently. So again, the two main things I worked on were an apparent bug in the audit plugin for iRODS, as well as adding a little bit of functionality for the HTTP client. So by way of an overview, the audit plugin is simply a rule engine plugin that emits a descriptive message for every state changing operation on an iRODS instance. The idea in both like concept and implementation is pretty simple but powerful in the sense that it enables you to have a full picture of what's happening on an iRODS instance at any given time. And so in order to talk about the bug, we first have to discuss the stack that it appeared in, which you can see illustrated here, where first of all, a state changing event happens. Cupid Proton is the C++ or originally C library that we use to send messages through AMQP, which is simply a queue-based messaging protocol. They are emitted in AMQP 1.0, but the RabbitMQ broker sends them out to Logstash, which has to, in some sense, translate them to AMQP 0.9.1. And then we'll talk a little bit more about what's going on inside that Logstash block in a little bit. But the point of it is that it gets to Elasticsearch and indexes them so that administrators can then search through those messages and get useful information out of it. So here we see an example of one of the problem messages that we were getting. You can see here we have a string of random bytes, as well as some extra backslashes beyond the normal escapes that you would need for the quotation marks. Originally, the workaround was to put these begin JSON and end JSON tags, and then use a Ruby syntax gsub filter to just strip out all of the bad characters because they could not be parsed as UTF-8. When iRODS 4.3 dropped, even that workaround stopped working. So finding a fix became important. And so as I hinted at earlier, or as you might have guessed, the problem was a lack of interoperability between AMQP 1 and 0.9.1. In the RabbitMQ documentation, it actually makes clear that these are essentially the same protocol in name only. And moreover, that 1.0 has seen limited adoption because it's significantly more complex. RabbitMQ does provide 1.0 compatibility, but it uses, since there's no standard for that interaction, anything that doesn't use or at least isn't compatible with RabbitMQ solution just will not have it. And AMQP Logstash does not have any plugin to parse AMQP1 as input. So what we wound up finding is that these random bytes that look like garbage are actually just valid AMQP1 headers that RabbitMQ didn't know what to do with. So then I first drafted, and Marcus improved significantly, this sort of improved version of a demo stack. So we have the same thing going on up here where AMQP sends a message, it goes to RabbitMQ, and then there's a little Python daemon running in the background that uses RabbitMQ's own client to pick up the 1.0 messages then send it to the Elasticsearch Python client for indexing, and then you can look through it in Kibana. So ways of doing this in the long term in a way that's more production ready. You could use AMQP 1.0. Like I mentioned, there's a little bit less adoption for that, but there are still softwares that use it. You could replace Logstash with something that speaks AMQP 1.0, or since Logstash is entirely plugin based, you could write or wait for someone to write an AMQP 1 or specifically Cupid plugin for it. And I realized to my horror that I forgot to change this to REST API. So for the rest of this presentation, pretend it says the REST API, which is just what it sounds like. It's a HTTP interface to the iRODS protocol, which provides a more simple and modern feeling entry point to interacting with an iRODS instance. It runs as a fleet of Pistache servers that are on the same machine as some iRODS service account. This isn't strictly necessary, but in the repo with the source code, you also get a pre-configured reverse proxy for Nginx, so you can run them through one port, and you don't have to worry about all those different addresses you might have to set. Servers bind routes to a specific strategy typed object that contains the iRODS logic in them. So like originally every function that you might want to use was its own separate server. So I wanted to add the ability to add, remove, or modify metadata on appropriate objects, as well as the ability to replicate and trim data objects and collections, and rename and delete them. And starting out this project, design considerations were that, as I mentioned, since all of those functions are their own server, we wanted to see if we could keep that from continuing to happen so that we didn't just have a ballooning number of servers as we needed to do more things. And we wanted to have an intuitive API in the format generally of like iRODS address /thing/action. So when it came to implementing the metadata parts, the iRODS specific logic turned out to be quite easy because there was already a high-level library available in the server itself. Architecturally, I addressed the executable numbers problem by introducing multiple strategy objects. So this endpoint allows bulk atomic operations on a single target using the RC atomic apply metadata operations API. And you format it this way. So here you give the entity name, a string, the entity type, and a string. So for example, some path data object, and then any number of operations that you want to perform on it. Next, we have the logical path endpoint. This houses all of the delete, rename, trim, and replication functions. The iRODS logic was trickier on this one since there wasn't a pre-existing high-level library. And so the API calls had to be constructed manually, sort of. It seemed like tricking things that were originally meant to be used from the command line. And then the next design goal was we had servers using multiple strategy objects, and we wanted to collapse those into one strategy object so that the server didn't have a ton of unnecessary classes that it had to hold state for. That said, we couldn't use static methods because the connection to the iRODS server requires a connection pool, which is stateful. So we needed to keep track of something. Each object now has multiple methods. They're called dispatchers, though that's probably not the best name. And they're passed to the request handlers via Lambda functions. So future directions that this might take, we have reports of sort of so Pistache is supposed to be able to automatically handle threading and things like that, but we have reports of serial behavior on higher workloads. And that could be addressed by refactoring our use of Pistache, see if there's a more efficient way that we could be using it. Or we could plug in a new framework. Some things that looked promising were OAT++, or specifically Drogon has what appeared to be some pretty impressive benchmarks for speed. In the future, the API could be standardized a little more in terms of how like the format that return values or error messages take. And also in terms of developer facing things, you could, I would like to modularize the strategy objects used to implement iRODS logic, because currently, say you want to make the logical path endpoint have some new function, and you just throw it in that file. But specifically for functions that require perhaps a lot of different subroutines to get their work done, that very quickly turns into a huge file that isn't very pleasant to read. So I'd like to make that a little bit more maintainable. And in terms of what I learned, I'd just like to reiterate what June and Violet have said a lot. The team has been wonderful. I learned everything I know about Docker, multiple AMQP implementations, Logstash, some extremely rudimentary CMake. I know more Git and GitHub than I ever expected to learn. And I learned a lot about writing idiomatic and efficient C++, as well as sort of how to approach a larger project, what you should expect, not to just like come in and write a ton of code that's awesome and then it all, magically gets merged, and how to manage, bigger workflows, get your head around a larger system, as well as softer rules that sometimes go unspoken or that perhaps one doesn't hear the same way unless you have been on a larger team. Specifically, I think a lot about, and I'm continuously trying to integrate Corey's advice about not getting frustrated with technologies you don't like, because there's probably a reason they're that way. And yeah, any questions?
So I guess my question is, what did you find was the most challenging part of taking on these projects?
Probably the two most challenging parts were probably thinking in terms of like the big picture of iRODS, like who's going to be using the software. Writing the code to get something done is fairly straightforward, but figuring out what you're trying to do is harder. Also, anything related to sort of the meta programming side of things. I found getting building environments and stuff to be pretty tricky.
Any other questions?
That's great. I've got one. Is there anything that you would do differently if you were to start over again tomorrow on this assignment?
The answer is definitely. What specifically would I do? Probably, I remember early on, I think when I was trying to track down what the bug was in audit, I read the UTF-8 spec one weekend and then panickedly messaged Alan and said, I still have no idea what's going on. And then I took a step back and, when the solution turned out to be more prosaic than that, I thought, maybe I should have looked at the obvious things first.
In your defense, we stared at it for 6 years and it was not obvious. So do not fret. Good job.
Thank you.
All right.